Now we will do some feature engineering here. We will create a new column quarter, which will mention the quarter of the year, the first quarter, second, third or fourth quarter. Okay, and we will insert this quarter column after this day of the year column here. Okay, so how to do this? We have to consider our data frame. As you all know, when we create a column, it is always created at the right hand side of the data frame, but we have to insert the column after this day of the year column. So here we will use the insert function, and here in this insert function we have to pass our first parameter, which will be index, where we want to enter the column. As the index of the columns also starts from 0, the OR is our index number 0, this is index number 1, index number 2, index number 3 and index number 4. So we have to enter the quarter column at our index number 5. Okay, so I will pass 5 here. The second parameter, our column name simple will be quarter. In this quarter column we want the quarter from the years, so we will consider the timestamp index here. Our data frame name data dot index. From this index value we have to consider the quarter. So like this, the command has been executed, and when we will see our data frame now, a new column has been inserted which is mentioning the quarter of the year. The January is present in first quarter and the December month is present in fourth quarter. Now in this data frame we can see the values in the columns are mentioned in the float format. We can convert this into integer format using the astype function. So these values are in float format. We can convert these columns into integer format. We will convert the data type of these columns or day of the week, month, year and day of the year into the integer format. So we will consider these 5 columns. On these columns we can use astype function. Inside this function we have to pass int here because we have to convert into integer. When we will run this, we have to pass our data frame name data here. When we will run this, the values are converted into integer. So we will save the changes in our original columns. Like this, the command has been executed, and let's have a look. Now here you can see the data type has been converted into integer, and this is our data frame now. Now we will create another column which is week of the year, that will represent the week number, means this particular date is from which week and this particular date is from which week of the year. And the syntax, as I told above, our data frame name dot insert function, first parameter our index number 5 here, second parameter our column name which is week of year, and third parameter what we want in this column, means the values. For this we have to use a special function which is isocalendar to extract the week from this timestamp column. So we will consider this timestamp column, our data, this is our index as you know of the data frame. So we have to consider the index of this data frame, and now isocalendar function. Let's see what is this isocalendar function. The isocalendar function is used to extract the ISO year or week number or weekday. Okay, so we have to extract the week number here. So we can pass here week to extract the week of the year, and we can also specify the data type here as type int, means we want the value in the integer format. When we will run this, The command has been executed and this is our data frame now. Here we have the column week of the year. Here it is showing that this is first week of the year. If we expand, what we notice here is this date 29 December is from our week number 52. After this date, the 30 December 2024 is considered in the first week of our next year, which is 2025. So it is showing 1 here. We can confirm this thing from the calendar here also. Okay, you can check this from here. The next thing is we will create a new column to check whether the given date is a weekend or not. So our data frame name dot insert, and this time we will place the column at the index number 7. You can choose any index number of your choice. Okay, and after this we have to mention the column name, and this time we will name the column as is weekend. Means the given date falls on any weekend or not. Okay, next thing we will use this index of timestamp. Means this date we will use data.index, and from here we will consider the day of week. Means Monday, Tuesday, Wednesday or Saturday, Sunday. If I show you in this data frame, the Monday is considered as 0, Tuesday 1, Wednesday 2, and Saturday and Sunday are considered as 5 and 6 respectively. So we have to check whether it is a 5 or 6. Okay, in this index date column. So for this we will use the isin function, isin, and here we will mention the value 5, 6. Means we want to consider Saturday and Sunday. When we will run this, the command has been executed. Now let's have a look at our data frame. We have a new column is weekend. It is showing false and true, means in Boolean format, and we can change it into the integer format. One method to change the data type of this column was that we can insert astype function here like this. It will automatically give the result in the integer format only, but when we will run this now, it will show error because at index number 7 this column has been already created. So now we can't use this function. So now we have to change this data type in our another line of code by considering this column is weekend and dot astype int. The command has been executed. When we have a look at our data frame now, the values are in the form of 0 and 1. 0 means there is no weekend, and when 1 is present means it is a weekend. We can check this also using the filtering week and equal to, we want those records where the value is 1. Okay, it is for showing in true and false, means Boolean, and to get the result in a data frame format we can write like this. So means on 4th January 2020 it was a weekend. Also on 29 December 2024 it was a weekend. Next we can check whether on a given date there is a public holiday or not. For this we have to import the holiday package. Now what is this holiday package? If we see here the holiday package, it is available in Pandas library. This package offers a comprehensive solution for identifying public holidays across over 80 countries. Okay, so we have to specify our country here while using this package, and it allows user to check if a specific date falls on a public holiday for a given country. You have to mention your country, and you can also mention your subdivision, and it can be easily integrated with Pandas data frame to add holiday information to time series data. So let's see how to add a holiday column. Import holidays. Now using this package holiday, first we have to mention the country for which we want to add the public holidays. I want to add the public holidays for India, and the short form here is IN. After this we have a parameter which is years, means for which year we want to check the public holidays, and here I want to check the public holidays from 2020 till 2024. So simply I will mention this column here, our data frame and year column. Okay, when we will run this, it will show the result like this. It will show all the holidays present in the given years. Now we will save the information in a new column of our data frame. Suppose the column name is holidays only. Holidays equal to this one. Okay, now when we have a look at our data frame, it will show the result like this, where NaN is present means there is no holiday, while other days are holidays. In this project we don't want to use this holiday column, so we will simply remove this column from our data frame, and the syntax will be data.drop and our column name holidays, and we will pass x is equal to 1 because we have to remove the column. The command has been executed. We will save this in our original data frame, and this is our data now. You can use this holiday column as per your requirement. Next we will create some lagged features. What are these lagged features? Let's first understand. These are the past values of a time series data. I will show some example also. What is the use of the lagged features here in this project? Here the past demand values are our strong predictors. Means these values can be used as input to predict future values. The lagged features enable the models to learn from the historical data and improve the forecasting accuracy. Now let's see how to create the lagged features with an example. Suppose we have a data, the sales data, and it is a time series of daily sales from Monday to Sunday, and we created a new lagged features. In this lagged features we will mention the sales of the last day, means here we will have a lag of 1. For first value it will see the sale of last day. As we don't have the sales of the previous day, so we have to mention here 0. On Tuesday we have to check the sale of last day, means Monday the sale was 20, so 20 will be mentioned here. Similarly on Wednesday it will be 45 because the sale was 45 here, and so on. Here we will have the sale of 50, then 30, then 75, and then 90. So this is our newly created the lagged features with a lag, or you can say step of 1. Similarly we can have a lag of 2, and it would represent the sales from the 2 days ago, and so on. In this case we will create 2 lagged features. First for the demand from the same hour yesterday, or you can say last day, and second feature for the demand from the same hour last week. Our first column will be the data and demand lag 24 hour, means what was the demand 24 hours ago. In this we will use the demand column, data demand. On this demand column we will use a function known as shift. The shift function is used to create the lagged features. Here we want the demand 24 hours ago, so I will pass a step, or you can say lag of 24 like this. When we will run this, and if we have a look at our data now, this is our new demand lag features, which will show the demand from the previous time point. Here if we expand this data frame, okay, in this column here we have a value of 2716 which is shifted from here the last time point of 24 hours ago, and we have a value of 2302 here which is shifted from here from the last 24 hours ago. So that's how the lag features are created. Here we have 24 null values because we don't have the data of the previous day. Okay, so whenever you will create a lag features, there will be some missing values or the few missing values in the starting. We will create one more feature here that will show the demands for the last 168 hours, or you can say 1 week. Okay, so data, my column name will be, you can choose any column name. I am choosing here demand lag 168 hours. It will be equal to the 1 week, and here we will consider the demand column again, and this time we will shift the value to 168. Okay, 24 hours into 7 days, so 168 hours for weekly shift. When we will run this, the new column has been created, and if we have a look at our data frame, this is our new column, demand lag 168 hours. In this column as well, the first few rows don't have any value because we don't have the data of the last week from this time series. For first week it is showing nothing. Let's check the values of this column, let's say after 168 hours. So I will take a sample using the iloc function. So here we will use the iloc function and we will consider the only row slicing or record slicing. So we can write our data frame name dot iloc. Here we have to pass the index value. I want to check for index from 168 till we can put any random number till suppose 200. So it will show the values. Let's change this to 160. Okay, here you can see it is showing the result from 7th January 2020. 168 hours will be completed from this date, 7th January. Okay, and if we check here the value, it is not a number, but after completing 168 hours on 8th January 2020, and we will check this row. Here we have a value of 2716 and 2302, and this is the same value, if you notice, that we have in the first week of the data, 2716 2302. So this is just for cross check purpose. Next we will create two more columns in this data frame. First one is for rolling mean and second column will be for rolling standard deviation. First understand what is this rolling mean and rolling standard deviation. These are the parts of a rolling statistics in time series analysis. Rolling statistics in time series analysis involves the calculation of statistical measures like mean, standard deviation or sum over a moving window of data points. If we talk about rolling mean, then it is also known as moving average, and it is a time series analysis technique that calculates the average of a subset of data points within a sliding window. I will show this with an example in Excel sheet, and this window moves across the time series, creating a sequence of averages that smooth out short-term fluctuations and reveal underlying trends. As in our actual data frame, suppose this is our data for first 24 hours from here. Okay, I will highlight this for first 24 hours, and when I check the rolling mean, or you can say mean of first 24 hours, the mean temperature we can consider here for this here it is showing that the mean average temperature is 10.2. okay, we will note it here 10.2. now we will move our window of this 24-hour from this second point to the next second point. okay, and here it is showing also 10.2. now we will move again our window from third point to this third point. Here it is showing that the mean average is 9.7. so this window will keep moving and it will show the result for each subset of our data points. If we do the same thing, the rolling mean for the demand column, then consider these first 24 values. The mean is coming 3809. I will write here like something, and our window will move to the next 24 values, start from here and end till here. Here the mean is coming 3798. 37 and what was 3798. okay, so and it will then move to the third window from here till here, and here this time the mean is coming 3742. okay, so this is the concept of rolling mean window. Let's create a column for the demand rolling mean for last 24 hours. So my column name here I am choosing demand rolling mean, and I am choosing a window of 24 hours. You can put any column name here of your choice. In this column, what we want, we have to consider the demand column, which is our target column also, data demand, and on this column we have to use a function which is rolling function. Inside this function we have to pass the window value, means how many values or how many subsets we want to take in a single window. We want a window of 24 because we have hour-wise data, so I am taking 24 here. okay, and after taking these values, what we want the mean of these values, so we will use the mean function on this. When we will run this, the command has been executed, and if we have a look at our data frame, this is our data frame and the demand rolling mean is now created. Let's see first 27 records for an example. Here I will expand this, and the rolling mean is here 3809. It is the sum of these values starting from 2716 and till 2896, and this is our window of 24 hours. okay, and for the next values starting from 2302 till here 2433, the mean value will be 3798, and this is equal to our these values that I explained earlier. okay, similarly we will create a new column that will mention the standard deviation for 24 hours. So my column name demand rolling standard deviation this time, and 24 hour equal to data, and I have to consider demand column again dot rolling, and the window size will be same 24, and this time we have to use the standard deviation function std. okay, and run this. The command has been executed. Again, if we have a look at our data frame, the column has been created demand rolling standard deviation for 24 hours. This value let me expand this, and here this value 959 is the mean, is the standard deviation of for last 24 values. okay, last, or you can say last 24 records of this data frame, and it is considering the demand column. So from here, starting from 2716, it is considering till this one 2896, and it is showing the value 959. In the next window, it will take the first value as 2302 and the last value as 2433, and the result will be 975. Okay, so that's how the standard deviation and mean rolling windows will be created. Next part is we will drop all the rows that have the null values. As you can see here, these rows have null values, so we can simply remove these rows to make our model accurate. So our data frame name dot drop NA function, and it will remove all the rows having any null value, and we will save this in our original data frame, and this is our data frame. Okay, now our data set is starting from the date 8th January 2020. You should know why it is starting from 8th January, and the reason is this one, that we choose the column demand lag 168 hours. When we created this column, you remember the values till 7th January 2020, there was the null values in this column. So we have dropped all these columns which is containing any null value, and starting from 8th January 2020, we don't have any null value in any row.